Today I'm going to show you the 3D model we are making to think about the whole overhead projector we're making. In this 3D model, as you can see, we made 3 different layers: the bottom, the handling tray and the head projector. What is quite important and what we can see in this model is that we need to get a really good alignment between the LED module, the table and the Fresnel lens specifically, and then the lens and the mirror on top of it. So here I draw you the model with the good lines. You can see this is the theory, and then when you will make the different layers of the object, you will have to draw the marks on the bottom, but considering the way it will be attached with the handling tray, so where the glass and the Fresnel lens are, and then the lens here. So what is quite important to you is to work on these alignments from the beginning. In the 3D model, you will find different useful information, such as the dimensions between the borders and the holes to put the threaded rods here. So basically we're based on 400 or 440 millimeters square sheet of wood here. And the idea is that you get some space at the corners that allow you both to attach the next level and to get the threaded rods in a nice way, so quite strong, not too close to the side, but also to get 2 layers of wood. These 2 layers of wood allow you to get first one the bottom and second one a small space, here it's 4 millimeters, to put a wall to close the whole object. We made exactly the same thing on top of here. We have a small layer here that allow to hold the Fresnel lens, but also to get this small space to put a wall to close the object. So this is quite important. What is not appearing in the model here is the different walls to close the whole box. Another thing that we drawn here is the back of the object. The back of the object is quite important because when you will put the LED light, here it's quite pure with nothing inside, but there will be some other stuff. Inside the box we'll get, of course, the LED module, but also the power supply and the DC to DC booster. Here is quite a pure image of the inside, but you will have to put it inside the box. Here we have a big hole to put a fan. The fan will be quite important when you have the different wall, because then you will be able to get the warm air out. Here we put it 2 holes. This is kind of the control panel for the people using the machine. So here is a hole that you can adjust. It's for on-off switch. And then here is a small hole to adjust the light. So it's the dimmer that you get with the machine and with the LED module. Talking about the handling tray, so this space where you can play the different visuals, we worked on different layers of wood which allow to get the Fresnel lens clean and really handled. Then we get other layers to attach the glass and to get a space in between. We start by making a plate here that is smaller than the Fresnel lens. Then we put another frame here that is, as much as possible, exactly the thickness of the Fresnel lens. This is a quite strong way to attach it, because then you will put another frame here with corners that are a bit cutted. These corners will allow you later to put the glass on top of it. So you can see here the glass is just on these angles. So this is a way to keep as much transparent surface as possible. Here we get the last frame, and this frame is super important, have to be exactly the thickness of the glass, because then if it's a bit more thick, you will get troubles with your visuals when you will put it on top of it. and you want to slide it or to make an effect with a movement, you will be stuck inside. So this is quite important to get the wood as thick as the glass. So here you can see in the model that there's nothing that is going on top of the other. Talking about the head now, this is composed by a tube or a wooden stick here that is attached. So here it's attached behind the model, but it could also be inside. It can also be in a corner. Here we made a model like the simplest, but what is important here is that you have to attach for a new system, a new model, an existing head with the mirrors that can rotate. The rotation is between 0 and 60 degrees more or less, and more often. So here is something you have to consider, because when you attach it, you have to get strong with the components that allow you to make the focus as well. So here we get a head that is the largest head we could find. So this is basically how we conceived it to be able to host the biggest head we got. If we go on top of it, you can see here I put it a little bit more wood on each side, which can allow you to attach with different systems some effects. So you can attach here easily layer of color if you want to get color to your image. You can attach different distortion effects. Behind that, the focus is the super important mechanical part. Here we made a model that is available as a 3D model, so you can print it. The important thing here is to consider that the gear is quite small and the handle is quite large. This way, when you make one movement, you get actually a large movement to go up and down, and also it's less difficult to get stability on your whole system, because you get less strength put it to the small gear. So here with the gear we model a gear rack. The gear rack allows you to get some linear in and out focus, so you can go up and down easily. All of it is inspired by already existing systems for focus in overhead projectors. So you can go up and down, and around here, which is a part that is open now, but that is of course closed, is a small box of wood that is put around an axis here. You can see this gray part, and this axis allows you to slide in a linear way and in a straight way between the head and the wooden stick and the thing attached to the model. Because the head is quite heavy, we put it here triangles to put as much as possible the weight on the wood panel that is just over here. As you can see, it's super in process. So we have now a model that we will share, and this model you can feel free to take it and to make a new one or to remix it if you want. But this is a basis to share different ideas together. So we worked on Fusion 360 to make this model, so it's a very common software to work. But if you feel like working on another software, please feel free. If you want to share something, just use our forum that is on visiophare.org, where you can discuss about it, and you can also see the different discussions there is around this object and its modeling. To host a file, we invite you to use Thingiverse as a platform to share open source objects and open source models, and then to share the link on the forum on visiophare.org. This model is based on parts that we assembled and we described in a previous video, so please feel free to check our website or YouTube channel to get it. We also have different files where we try to put all the blueprint of the objects as it is evolving. Thank you for watching this video. As you've seen, there are many things to improve, create or remix, so please feel free to participate to the community.
You can follow us on Instagram, you can go on our website visiophare.org, where we have a lot of documentation and blueprints we share for free to help you build your own overhead projector or convert your original one with LED. Feel free also to go on the forum of Visiophare to share your builds, ask your questions, share your ideas, and together I'm sure we can improve a lot the possibilities of this fascinating machine. Thank you and see you soon.
Thank you.